Isaac Newton, born on Christmas Day in 1642, was a tiny baby, premature and not expected to survive. His father, also named Isaac, had died just 3 months earlier. He grew up in a small village in England called Woolsthorpe. Young Isaac was a curious child, always eager to learn and explore the world around him. At the age of 12, Isaac was sent to the King's School in Grantham, where he lived with a local apothecary. He showed an early aptitude for mathematics and science. He built sundials, water clocks, and even a model of a windmill. Isaac's mother wanted him to become a farmer, but he was clearly destined for greater things. His intelligence and thirst for knowledge could not be contained. At the age of 18, he left for Cambridge University to pursue his true calling. Cambridge University was a hub of intellectual activity, and Newton thrived in this environment. He immersed himself in the works of great thinkers like Galileo, Kepler, and Descartes. He was particularly drawn to mathematics and its power to explain the natural world. One professor, Isaac Barrow, recognized Newton's extraordinary talent and became his mentor. Barrow encouraged Newton's independent thinking and helped him develop his mathematical skills. These were formative years for Newton, laying the groundwork for his groundbreaking discoveries. Newton's time at Cambridge was interrupted by the Great Plague of 1665, which forced the university to close. He returned home to Woolsthorpe, where he spent the next 2 years in solitude, contemplating the mysteries of the universe. It was during this period that he made some of his most important breakthroughs. During his time at Woolsthorpe, Newton developed a new branch of mathematics which he called fluxions, what we now know as calculus. This revolutionary tool allowed him to describe motion and change in a way that had never been possible before. Calculus was a major breakthrough, but it was just one of Newton's many contributions to mathematics. He also made significant advances in algebra, geometry, and infinite series. He developed the binomial theorem, which provided a powerful method for expanding binomials. In 1687, Newton published his masterpiece, Philosophiae Naturalis, Principia Mathematica, Mathematical Principles of Natural Philosophy, often referred to as simply the Principia. The Principia was a groundbreaking work that presented Newton's 3 laws of motion. These laws explained how objects move and interact with each other. The first law stated that an object at rest will stay at rest, and an object in motion will stay in motion at a constant speed and direction unless acted upon by an unbalanced force. The second law explained that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. The third law stated that for every action there is an equal and opposite reaction. Perhaps Newton's most famous discovery was the law of universal gravitation. This law stated that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law explained why apples fall from trees and why the planets orbit the sun. Newton's laws of motion and gravitation revolutionized our understanding of the universe. They provided a mathematical framework for explaining the movements of celestial bodies and laid the foundation for classical physics. Section 5. A spectrum of discoveries and Newton's work in optics. Newton's scientific curiosity was not limited to mathematics and physics. He also made significant contributions to the field of optics. In the 1660s, he conducted a series of experiments with prisms and light. He discovered that white light is actually a mixture of different colors, which he demonstrated by shining a beam of sunlight through a prism and observing the resulting spectrum of colors. This discovery led Newton to invent the reflecting telescope, a new type of telescope that used mirrors instead of lenses to focus light. Reflecting telescopes were superior to the refracting telescopes of the time because they did not suffer from chromatic aberration, a distortion that caused objects to appear fringed with color. Newton's work in optics had a profound impact on astronomy, allowing astronomers to see farther and clearer than ever before. Section 6. Legacy of a polymath, later life and achievements. Newton's groundbreaking work in mathematics, physics and optics earned him widespread recognition and acclaim. In 1689, he was elected to represent Cambridge University in Parliament. He was appointed Warden of the Royal Mint in 1696, a position he held until his death. In 1703, Newton was elected President of the Royal Society, England's prestigious scientific organisation. He was knighted by Queen Anne in 1705, becoming Sir Isaac Newton. He continued to publish and refine his work throughout his later years. Newton's later life was marked by controversy as well as triumph. He engaged in a bitter dispute with Gottfried Wilhelm Leibniz over who invented calculus. The controversy cast a shadow over Newton's later years, but it did not diminish his legacy. Section 7. The enigmatic genius, personality and working style. Isaac Newton was a complex and enigmatic figure. He was known for his brilliance, but also for his solitary nature and secretive working style. He was deeply religious but unorthodox in his beliefs. He was a devout student of alchemy, a practice that was considered heresy by many at the time. Newton's solitary nature and obsessive work habits may have contributed to his groundbreaking discoveries, but they also took a toll on his personal life. He never married and had few close friends. He was prone to bouts of depression and paranoia. Despite his personal struggles, Newton's scientific achievements were nothing short of extraordinary. He was a true polymath, a master of multiple disciplines who made groundbreaking contributions to our understanding of the universe. Section 8. A legacy etched in time, Newton's enduring impact. Isaac Newton died on March 31, 1727 at the age of 84. He was buried in Westminster Abbey, an honour reserved for the most esteemed figures in British history. His legacy continues to inspire and influence scientists, mathematicians and thinkers to this day. Newton's laws of motion and gravitation laid the foundation for classical physics and revolutionized our understanding of the universe. His work in optics led to the development of new telescopes and advanced our knowledge of light and color. His invention of calculus provided a powerful tool for scientists and mathematicians, enabling them to solve problems that had previously been intractable. Isaac Newton was a true giant of science whose work continues to shape our world today. His legacy is a testament to the power of human curiosity, ingenuity, and the relentless pursuit of knowledge.